This video is a review of two-step inequalities. And the first thing I want to review are the symbols that you come across. So you have this one. This one, look, I love you. Look, I drew a heart for you. X is greater than, ooh, oh, I said the name of it. Okay. All right, so the first symbol is greater than. All right, so if I want numbers greater than 3, and that's what that means, numbers greater than 3, it's not 3, but it's all the numbers bigger than it. So 3.00001 would be included, but not 3. If I want to include 3, we would say greater than or equal to. Okay, so that would include the 3. So let's talk about graphing those. Do a real simple graph. So here's 3, here's 3. If I want all the numbers greater than 3, I wouldn't include 3, so I'm going to do an open circle and all the numbers greater than it. So all those numbers give me a true statement. 5, that's greater than 3. 6, that's greater than 3. So everything that's shaded there is what gives me a true statement when I put it back into the inequality. Since on this one I want to include 3, I'm going to fill in the circle and say all numbers. Because 3 is greater than or equal to 3, 4 is greater than or equal to 3, 5 is greater than or equal to 3, so all those numbers are. The other two symbols are less than. So this one's less than, actually I should put is greater than, is less than, is greater than or equal to, is less than or equal to. Because if I say just less than, that actually means subtraction. So is less than. Make sure I have that distinction there. All right, so if we talk about numbers that are less than 3, then I would say, okay, 3 but is not included, but everything less than it is, like 2.99995. That's less than 3. So that'd be included. 0, less than 3. So that's a shade of all the numbers that would give me a true statement. If I want to do less than or equal to, again, I'm going to fill in the circle, and it's all the numbers less than. We say it goes towards negative infinity. If it goes in the opposite direction for greater than, we're saying that goes towards positive infinity. So those are your symbols: greater than, less, is greater than, is less than, is greater than or equal to, or is less than or equal to. So solving inequalities is a lot like equations. When I'm adding and subtraction, I don't do anything different than I would do an equation. I don't change any equality signs or anything like that. So if I had like x plus 3 is less than 8, or let's say I had x minus 3 is less than 8. When I go to solve these, I solve them just like an equation. I think opposite. So subtract 3, x is less than 5. So any number less than 5 would give me a true statement in that. So 0 plus 3, yep, that's less than 8. On this one, I would add 3. So x is less than 11. So any number less than 11 would work with that. So let's see, 10. 10 minus 3 is 7. Well, that's less than 8, so that works. The same thing goes when I'm multiplying or dividing by a positive. All right, so if I'm multiplying or dividing by a positive, the same rules apply. Just solve it just like an equation. Divide by 3. X is less than negative 6. So any number less than negative 6 will give me a solution there. So like negative 10. 3 times negative 10? Yep, that's negative 30, less than 18. For this, I multiply times 3. So I get x is greater than or equal to 15. So any number greater than or equal to 15 will work in that. 20. All right, let's do one evenly. 24. 24 divided by 3 is 8. That's greater than 5. The difference comes in when I multiply or divide by a negative. Then that will cause us to change our inequality signs. So let's look at the same questions, but with negatives. So on this one, I'm going to divide by a -3. When I divide that by a -3, I have to change the direction of the inequality sign. So -8 divided by -3 is a +6. And you might say to yourself, okay, why did I have to switch to the inequality sign? So let's look at that real quick. So let's say I have 5 is less than 10. That's a totally true statement. If I multiply both of those sides by -3, now I have -15 and -30. Well, -30 is actually less than 15. So to keep a true statement, I have to change the direction of the inequality sign. So that's why when you multiply or divide by negative, you have to change the signs. So, like here, I'm going to multiply both sides by -3. Because I do that, it now becomes less than or equal to -15. So I have to switch. So, to kind of summarize everything we said here, and then we'll do some examples. Solving inequalities is like an equation. However, there's some differences. One is my solution isn't a number. It's like x is bigger than a number, or less than a number, or greater than or equal to. So my solution is the variable, the symbol, and the number. I need to have all three things. Sometimes I'm going to be asked to graph my solutions. So I have to graph them with open and closed circles and arrows pointing in the direction. And then one of the biggest things I need to remember is when I multiply or divide by a negative, I got to change the direction of the inequality sign. So let's do some examples. We're going to do, let's do a couple. So let's at least do 2 and we'll go from there. All right, let's do 3. Let's do 3 examples. And we'll graph the solutions as well. Now, you won't always be asked to graph the solutions, but you will always be asked to write your solution with a variable, the inequality symbol, and a number, and when you multiply or divide by a negative on both sides, that you switch the sign. All right, so let's look at number 1. Just like a two-step equation, I'm going to get rid of the subtraction first and then the multiplication, again, unless it's part of a grouping symbol. So I'm going to add the 6 first, and I get 3x is less than, I almost put less than or equal to, is less than -6. I'm going to divide by a positive, so since I'm dividing by a positive, I don't need to switch the sign, even though I'm getting a negative solution. I don't need to switch the sign. So my solution is this whole thing. If I just give, like if you just give me -2 as a solution, it's not right. In fact, -2 is not even a solution to this. It's numbers less than -2. Okay, it's not even or equal to. When I go to graph this, and there'll be more numbers on your number line when you do that, but it's open circle and it's all the numbers less than. Okay, all the numbers less than that. So 0. Nope, 0 is not less than -2. -3. All right, let's look at example 2. All right, next example. 2-step, get rid of the subtraction first, and then the multiplication. So I'm going to add 9 to get rid of the -9. I'm going to divide by -4. I'm going to divide by a negative to get rid of that. All right, add 9. -4x is less than or equal to 12. Divide by -4. I divide by a negative. So now I'm greater than or equal to the old switcheroo. Okay? Now, my solution again is the whole thing. X is greater than -3. That the whole thing is my solution. If I'm going to graph this, it's or equal to, so it's a filled in circle, and it's all the numbers greater than -3. What's kind of nice, if you notice, I see how my inequality, if you look at it, it points this way, and my graph went that way, and on this one it pointed this way, and my graph went that way. Now that only works when your variable's on the left-hand side. If it's on the right, it's actually going to be opposite. Okay, well that's kind of helpful to know. All right, let's look at our final example. We want to get rid of addition and division, so we're going to subtract and multiply. So, subtract 3. X divided by -6 is greater than -3. And now I'm going to multiply both sides by -6 to get rid of dividing by -6. I get X is less than, because I multiply by a negative on both sides. And negative times a negative is a positive. So my solution is X is less than 18. So any number that works has to be less than 18, so open circle, and it has to be less than that. So 0. 0 divided by -6 is 0, plus 3 is 3, and 3 is bigger than 0. So I know I did that right. So inequalities solve just like equations, except for when I multiply or divide by a negative, I switch the inequality sign. Sometimes I'm going to be asked to graph my solution using open circles for less than and greater than, closed circles when it's or equal to. And my solution isn't just a number. So for instance, number 3, it's not just 18, it's X less than 18. So I need to write that whole thing as a solution.